Hi everyone. I'm Akın Ünver from Özyeğin University. So what I want to do right now is to do a very basic introduction to using R to get and visualize Twitter data. This is nothing advanced. It's not even intermediate. It's like the most beginner version possible. So if you're interested in more advanced stuff, I can't share screen, by the way. Can you please make me share screen? So this is like absolute beginner's guide to doing some social media analysis with R. Just like I requested early on, when you look at the chat, if you have come prepared with these, we can all do this together in real time. If you haven't, then since this is recorded, you can always return back to the video and do these on your own. In order to be able to do these, we need R. I have nothing against Python. I love Python, but it's easier to teach these things in R. So what we do is that first, we are going to have to download what we call the base R. So let me share my screen. So the base R is actually downloaded from the Comprehensive R Archive Network, which is CRAN for long. What CRAN does is that every single R-related package, at least most of them, are in the CRAN network. When you're installing a package, when you're installing R itself, you basically download it from the Comprehensive R Archive Network. And depending on whether you're using Linux or Mac operating system or Windows, you essentially download the base R. Now, after you download the base R, what we need is the RStudio. Now, RStudio gets base R and makes it easier to work with and more, how do you say, user-friendly. So when we download and install the base R, we then go download and install RStudio desktop. And again, when you try to install it, it says first go back and install the base R, the most fundamental core R, and then install RStudio for desktop. So that's essentially what we're going to need. Now, as I said, this is going to be very basic. I'm assuming nobody has, prior information or prior training with R or prior training with social media analysis. If you are looking for more advanced stuff, we got you covered as well. So there's this thing called the Summer Institute in Computational Social Science. Now, summer institutes in computational sciences have been around since 2017. In Istanbul, we started running this in around 2018. So just 1 year later, we actually had, where is Istanbul? I can't find my site, probably in the past places we're going to find it. Let's see. So we basically did the first Summer Institute in Computational Social Science in 2018, then in 2019, then 2020, then 2021. This year in 2022, we took a break because it's very tiring. But essentially, this coming year in 2023, we are going to run this together as Özyeğin, Koç, Sabancı, and Boğaziçi all together coming together and organizing one single Istanbul Summer Institute in Computational Science, Social Science. And this is, I would say, the best event in the world that you can attend if you're interested in computational social science. You don't have to come to Istanbul, but you can attend something in London, you can attend something in New York and Harvard. So this year, we are going to do this in around June, and I think it's going to be the best summer institute so far. But prior to coming to the summer institute, you can actually learn online yourself. We have Summer Institute of Computational Social Science.io/overview, and we have tons and tons of R tutorials and exercises that take you from like very beginner, essentially basic programming, basic visualization, R basics, and all the way to bag of words analysis, randomized field experiments online, ethics, APIs. So this is actually a very valuable video collection. So if you're interested in more intermediate to advanced stuff, you have free online sources available. But what I'm going to do today is actually do a very basic explanation of what social media analysis is and how to do it in a very basic fashion. So as I requested early on, for those of you who already have downloaded base R, those of you who already have downloaded the R Studio, and those of you who already have an active Twitter account and already on your default browser on the day of the workshop. So for those of you who came prepared, you can follow through with me. So what I'm going to do right now is that I'm going to share my screen in the tutorials section. Can all of you see this well? My base R. So please turn on your RStudio sessions. A fresh session. When you open this up, probably you are going to see a page like this. So the first thing we do is with RStudio is that we open up a new R script, an R, base R script. So R has 4 quadrants. The northwestern quadrants, which is here, which is the module, the terminal in which you input code. The north eastern quadrant, which is the environment, history, connections, and tutorial pane, is the place where you're going to have your objects and data stored at. The southwestern quadrant is your console and terminal sections. This is where the output is going to come up. And you are going to have the quadrant, which is about southeast, which gives you files, plots, packages, viewer, and presentation pane. So essentially, what we're going to do right now is that I've prepared some data, some code for us to work with. So just type along with me as I type this. You can follow through with me. So the first thing we always do when we're beginning a new project usually is that we start to install packages. So similar with Python, R also has a very robust and a very active package ecosystem. Anything you want to do with R, anything you want to do with Python, you do with you do these with packages. And where those packages in R, where they come from, is the comprehensive R archive network, the same place from where you downloaded the base R. So the first command that we're going to enter is, I'm typing very slowly so that you can follow up with me. In order to be able to both follow me and also type at the same time, take the Zoom screen on the top of your own screen and cover the half of the screen with my tutorial, and open up your RStudio session and basically minimize it on the other half of your screen so that you can simultaneously follow my code from the top and input in your own R session at the bottom. That's the best way to follow live tutorials. So what we're going to do is to type install packages. So first thing you're going to notice with RStudio is that when you start typing a command, it is going to give you some suggestions, suggestions, packages, and methods that contain the term that you're trying to input. This is very useful and comes from the RStudio capabilities. In base R, you don't have this, but we're basically downloading RStudio on top of base R so that it becomes easier to work with. So every single time you're typing a new command, R will try to guess what you're trying to input and give you suggestions. So you can basically pick what you want with the mouse. But if you're an absolute beginner, I suggest you type the full code, because as you can see, there are very similar and confusing commands like install packages, installed packages. And if you're not, at least have some mileage with R, it's very difficult to discern. So what we're going to do right now is just say install packages. Now, how do we get social media data into our R sessions or Python sessions? We do those through packages that utilize what we call as application programming interface, or API. Now, what is an API? You can think of an API as a bridge. It is a bridge that connects a particular program or an application to another program or an application. So I think our previous speakers spoke extensively about Twitter API. What Twitter API does is that it offers up a bridge of data that connects to a different program. So in this case, we're building a bridge between Twitter and our R session, our R code. And we're doing this thanks to the application programming interface. And in order to utilize Twitter's application programming interface, we can use certain packages. So one package that academics use, Ali Abad Hoca mentioned it early on, is a package called Academic Twitter. You don't have to write this. This is just name of the package. But it's harder to teach because it requires validation, and they have to, vet you. You have to, submit them a proposal or whatnot. The easiest package to teach is RTweet. So RTweet is becoming a little bit obsolete due to API changes of Twitter. But it's still around. It's still, useful in order to be able to teach how to do these things early on. There's somebody in the chat. Attendance is okay. That's not relevant for me. So the first thing we're going to do is that we are going to install this package. Now, how you install a package is that you type install dot packages, parentheses, quotation mark, whatever package you're installing, close the quotation mark and close the parentheses. So when you write this, in order to be able to run it, you have to go and click on the run pane, which is in a place that I'm pointing to. So when I run, it is going to go into the comprehensive R archive network. It finds the package called RTweet. If there's no package as such, it's going to give me an error and says, I can't find any of that package in the CRAN, so something is wrong. But for now, we said RTweet. RTweet exists in CRAN, so we downloaded RTweet. The second thing we need for, not just for this project, but for most our project, is to install another package called the tidyverse. Now, the tidyverse is going to actually, oh, yes, install packages. I made a mistake. Install packages tidyverse. So downloading tidyverse is generally a very useful thing because tidyverse is a collection. Think of it as like a box of the most useful packages that you use in R related to data manipulation, data cleaning, data wrangling, data visualization, data management, anything that you do with like matrix data. Tidyverse contains a lot of like subcomponents like dplyr, per, all other sub packages that make it easier to work with data. So what I want you to do is to type install packages rtweet, install packages tidyverse, click on run. It is going to take some time until your computer connects to the CRAN and starts downloading those packages into your environment. Now, tell me when your download is complete, because on my computer, they're already downloaded, so it's faster. But with you, I'm assuming that it's going to take a little bit longer. So let me know when the download is complete. Just somebody says just say complete, or like in one way I can understand. Done, complete. Okay, cool. So I am continuing. So when you're downloading a package for the first time, you use the command install packages. If you have already installed a package, and every single time you have to reintroduce that package to your new session. Let's assume that you are doing a project on, looking at top trending topics of the World Cup. You already downloaded rtweet and tidyverse. You don't have to reinstall them. But what you need to do is that you have to introduce them to your library. So you have to use the library function. It kind of operates as the load function. So instead of load, we use the library function. It means, get this package introduced to this particular session. So we already downloaded rtweet. So I am going to introduce rtweet to this working session that I'm working on. When you just click on run, it is going to get the rtweet that you downloaded and introduce to this particular session. The same thing goes for the tidyverse. We have downloaded it. After you have installed a package, you don't need to reinstall them ever again, but you have to get R to acquire that package from your computer, and into this specific session, you have to use the library function. And I'm doing the same thing for the tidyverse. Now, we have installed and loaded a package, which is good. Now, the second thing that we are going to do is, it's very critical, like pay attention. So for an API to work, it needs some kind of validation, because an API is a bridge. It's kind of like an agreement between you and whichever platform you're trying to connect. So an API is kind of like an agreement that says, I am getting data from you, but I'm getting data from you as part of the principles that you outline. So I'm doing things in a legal and acceptable manner. I'm not scraping data. So scraping, in very rare circumstances, you may need it, but I don't really recommend it. Scraping is, it's sometimes illegal. In some other times, it's really not preferred because you get banned, your IP gets banned from the website altogether. API is nice, tidy, and a gentlemanly way of doing things. So the first thing is that we have to authenticate ourselves to Twitter. Twitter should recognize us, meaning that I know you, as whoever you are trying to get data from me. That is why I requested specifically at the beginning of this workshop that have a Twitter account and get it logged in with your main browser, because the next command that I'm going to input is going to validate your Twitter account so that you will be allowed to get data from Twitter. And that command is authorization setup default. So this command basically is a command that is from the RTweet package. It establishes a legitimate and legal connection between your R session and Twitter. So when you say authorization setup default and run it, I'm already authorized, so it's not doing anything, but most likely it's now on your computers, it's trying to connect to Twitter and it's asking you to authorize our tweet. Say yes to that authorization. So when you run this authorization setup default, it automatically goes to your browser and automatically opens up your Twitter. And on the Twitter, it should give you a page in which it says, are you going to authenticate our tweet? Do you want to link our tweet with your account? And you have to say yes to that, because otherwise you will have to operate another package called academic Twitter or Twark or any other, Python packages that require acquiring specific API keys, and that's more complicated and it's longer to teach. So this is the simplest way of doing these things in a short amount of time. So how many of you have done it successfully? Let me look at done. Okay, so people are actually doing it, which is very, very good. So after you have established some authentication, and this is basically the same thing. If you're operating Python, if you're not using like illegal packages, I'm not going to name names, but if you're using Python, you essentially have to follow a similar procedure. You have to get an API key and an API code, and then introduce them to your Python session and get validated by Twitter, and only then collect data. That's not unique to Twitter. If you're trying to use Facebook data, if you're trying to use Instagram data, if you're trying to use like New York Times API, if you're trying to use NBA data or World Bank API, you need some kind of authentication, which essentially says that, I'm a real person. I am doing legitimate research with your API. So now we are done with setting our authentication and installing the required packages. Now, what should we research? Now, I'm going to stop share and let's see what we can do a research for. Now, there's several things we can do research, but my specialty is always, wars, conflicts, and all that nasty stuff. So go to newsgoogle.com. I'm also trying to get you to think like a social media analyst, because even if you know the technique, the second question is always, okay, then what am I going to do research on? So my area of specialty is, wars and conflicts and all of that nasty stuff. And I'm interested in the war in Ukraine. So the first thing that I do on places like Google News is that I type Ukraine war and type enter. So I'm getting a list of top news about the war in Ukraine. And there's this Guardian piece that says Russia-Ukraine war, Ukrainian missiles attack Russian-occupied Melitopol. Why? Okay. So I'm clicking on that Guardian link. Russia-Ukraine war, Ukrainian missiles attack Russian occupied. Fine. So Ukrainian missiles hit barracks, Kherson, whatever. So I'm basically fishing for keywords that that I can do a keyword search on. So for those of you who may or may not know the course of the Ukraine war, one of the reasons for successes of Ukraine against Russia, it's the same news here in Al Jazeera. Ukraine is attacking Melitopol with missiles. Now, the kind of missiles that Ukraine is using is a very specific kind of missile called HIMARS. So HIMARS is a long-range rocket, a long-range missile that's manufactured by Lockheed Martin in the United States. And it's basically a long-range firing system. And quite interestingly, when you do kind of trend analysis, and let me show you how I do trend analysis as well. I go to Google Trends, and on Google Trends, when I try to, explore themes, and when I add, HIMARS as a search term, something that I notice in Google Trends is that HIMARS, a weapon system, was unpopular, and then suddenly with April, it starts to become more popular. And this is interesting. Now, there's similar weapon systems that are being used in Ukraine, such as like the Javelin, for example, which is the weapons system, which is actually more popular than this, or Bayraktar drones, Bayraktar TB2. So these are all like very popular weapons of the Russia-Ukraine war. So Bayraktar became very popular around this time, and as the course of the war progresses, you see HIMARS are becoming more important. So interest in HIMARS in Serbia, in Vietnam, in Russia, interest for Javelin, but that's another Javelin for Bayraktar, of course, Turkey, Ukraine, Iran, and Poland. I'm interested in this HIMARS keyword. I want to do an analysis of this, because when I look at the world's map, HIMARS is very, very popular in Ukraine because it's heavily dependent on those long-range missiles in order to be able to make a difference against the Russian artillery. So the keyword that I'm picking right now is HIMARS. I fished for my keyword. I shopped successfully, and it's good to be able to right now try that keyword. So we are going to get data, but when we get that data, we have to put it somewhere. We need a box. We need a container that's going to hold all of that data. In our language, we call that an object, a box that holds your data together. And in order to be able to create an object, we use the symbol, which is arrow, smaller sign, and a dash. So this guy right here is the object formation symbol. In Python, it's the equal sign. For those of you who come from a Python background, would use the equal sign as part of it. In R, we don't really use equal for that measure, because in R, we're doing a lot of mathematical computation and calculation, and we need equal sign for other purposes. So we have to separate that mathematical equal sign from the object identification equal sign. So what we're going to do right now is that we're going to create an object. So I'm naming this object as HIMARS data. It is going to be the box or the container in which I'm going to put my Twitter data into. So HIMARS _ data. For those of you who are doing this the first time, don't put any like space. Don't do this. Like don't do HIMARS space data because it's going to mess everything up. If you're defining an object with 2 or 3 or more keywords, connect them to each other with an underscore at all times so that you don't get into trouble. So HIMARS _ data. So how do we get Twitter data? The most important and exciting part. So we are using the rtweet package, and the rtweet package has a command called search tweets. Search tweets is the command that connects your R to your Twitter account and your Twitter account into Twitter API and Twitter API into Twitter database. So by using search tweets function, I am connecting to live Twitter database, and I have to introduce some kind of conditions for it. Okay, what do I want? What kind of Twitter data do I need? So I am specifying a keyword now, and I'm specifying the keyword with double quotation marks. And what was my keyword? It was HIMARS. I'm interested in how people are talking about HIMARS on Twitter, whether there are any interesting, changes to its frequency over the last few hours or the last few days. Chats. Is this case sensitive? It can be. Most of the time, what we do is that we use both, because since we're getting Twitter data, it's very important to be careful about the fact that people write things in tons of different ways. So some people, when they're typing a tweet, like when they're tweeting something, they can say things like, "Oh, I love HIMARS, so cool." So they can write this as that way. They can write that in a more legitimate fashion. There are strange people that even do like HIMARS, that kind of silly kind of stuff. But we can't really use that. We can either use HIMARS or we can either use HIMARS as a lowercase. But right now, what I'm interested in is HIMARS, because my observation with how people talk about this specific weapon on Twitter is that they tend to use them uppercase. Of course, you're going to try certain things. Experience is the most important thing in this context. You have to do some trial error. So I have specified my keyword. Now, don't run this. If you run this, it is going to basically run for hours and hours and days and days and days until it gets all HIMARS related tweets. Is it a problem using Turkish letters like Ü, O? I'm looking at your questions at the same time. I mean, it depends on, so if you're using, if you're doing like a Twitter analysis of a Turkish keyword, you have to use Turkish letters, so there won't be a problem. But of course, with regard to your commands, you can't use any Turkish keywords. For example, if we have been doing like the Twitter trend analysis about Turkey, we would have to write Turkey like this and not Turkey like this. We would have to do Turkey. If we were to do do like a trend, I don't know, trend analysis of Chorum, you would have to write Chorum like this with che, not je. So when you're doing keyword analysis, you have to, it should specifically match whatever you're using. So we are going to add a comma here after HIMARS because we're going to introduce our second command here. And our second command is going to be how much tweet do I want, which means what is my number of tweets. So this is very critical because if you don't introduce an n, it's going to basically get HIMARS data until infinity. So we don't want that. We want a specific threshold. We want a specific number so that we start, doing some analysis. But if you're doing like a big project, like a major project, like a, I don't know, NATO-funded project that wants everything, then you would have to run several computers all the time, 24 hours a day, 7 days a week. They should be collecting these data in real time. They would be collecting data all the time. But for our purposes right now, we're not using strong computers like that. So we have to be very modest in terms of how much data we can work with. As a trial, we can just start with 2,500 tweets, because the real interesting thing here is actually not even that. Let's first get like 250 because we're not going to visualize this right now. I'm going to show you what Twitter data looks like. So I just want like very small 250 tweets that contains the keyword HIMARS. And then another comma. I don't want retweets, which means that when I get HIMARS related tweets, it's going to give me tweets that are also retweeted. So if there's a tweet about HIMARS that is very, very popular and it was retweeted 3,000 times, 4,000 times, my entire data set will be made up of all of those retweets. So I'm going to get the same tweet over and over and over again, retweeted by multiple people. I don't want that. So that's why I don't want retweets. And the way I'm going to tell R that I don't want retweets is through command include underscore retweets equals false. So this means that I don't want retweets. I just want 250 organic tweets that are just written as it is, containing the keyword HIMARS. So when our tweet gets these data, then it is going to assign them to a box, an object called HIMARS data. So what I'm going to do right now is that I'm going to come to the end of this line and then hit run. Now, since this is like a very small Twitter data, it's downloaded very quickly. So most of you who did this correctly should have, let me see, do I have some kind of laser pointer? I would have to, I should be able to, do you guys know where the laser is? There used to be a laser somewhere, because I don't think you can see my cursor. I need some kind of like a pointer to be able to show. And is it in the annotates? Mouse select. Anyway, there used to be a laser somewhere around here, but I don't think it's anywhere. But anyway, when you look at your environment pane, which is in the northeastern quadrant, you are going to see that you have your data now. You have HIMARS data, 250 observations, which means 250 rows, which with 43 variables. Now, what I want from you is that click on this HIMARS data, which is on your data tab. When you click on that HIMARS data, it opens up your tweet database, the tweets that you have downloaded, essentially. So let's explore this a little bit because it's very important. Before visualizing anything, because before analyzing everything, we first have to be very intimate with the kind of data that we're working with. So for those of you who are doing this for the first time, let me look at, I'm getting an error of, so when I'm typing, it's very difficult for me to follow the chat. So if somebody else can follow the chat for me, because my full attention is on the screen, I can't really follow Zoom. Just like whoever is running this session, it should please like tell me verbally what these questions are. Are these tweets selected randomly? These tweets are selected not randomly, but beginning with the time that you sent a request, it goes back chronologically and basically gets the tweet from 1 second ago, 2 seconds ago, 3 seconds ago, 4 seconds ago. So it basically goes chronologically backwards. Twitter allows for these tweets posted in the last 7 days, right? I think it changed very recently. It should be longer than that. It should be 21 days or something. I'm getting an error, unfortunately. We have to, turn back later on. There should be something about either the code. There should be something about code. There should be something about the authentication. You have to, yeah, I mean, I can't really do troubleshooting right now, but this is recorded. I have to run very fast because we haven't even gotten. So it says search tweets. It says could not find for search tweets. It means you haven't installed the package rtweet. You haven't installed it into the library. Go back in the full code and do these like very specifically and carefully. Yeah. So thanks so much. So let's look at this HIMARS data. So I have certain variables here now. So each of these rows are a tweet data. So we have created at data, which means which date and which time it was created at. The ID, the numeric ID for the account that tweeted it, ID string, the specific unique identification for that particular tweet. Most of the time we are going to use this, the full text of the tweet. As you see, they all contain HIMARS, HIMARS, HIMARS everywhere. So these are all tweets that that contain the keyword HIMARS. Truncated, which means when you are resharing a content from another website and the text is greater than Twitter's character limit, it truncates, it shortens it. So whether it's truncated or not, the display text range, I can't really fix this right now. Entities, metadata, source in reply to screen name, coordinates, place, contributors, is code. So if this is your first time with Twitter data, it's usually a good idea to spend more time on this in this particular page after this tutorial, because people are doing really creative stuff with these different variables, like timestamps that they're being used for different purposes. When you're doing network analysis, you need followers and followed data. you need reply to data, you need favorited data. So this is essentially what a raw Twitter data looks like. The language of the tweets, the text range, how many characters it has, metadata about its popularity rating, its source, whether it's reply to another tweet, in reply to status ID, in reply to user ID. So Twitter data is actually very, very detailed. And there's the kind of research, the kind of interesting analysis you can do with these things is really infinite. But for now, I'm going to basically produce a very simple graph. But for me to be able to produce a simple graph, so we downloaded 250 tweets, which is not really that much. Let's up the gear and let's download 15,000 tweets, like something that we can really work with. Now, since we're using API, which is legitimate and legal way of getting data, there are limits. And those limits, you can actually go to Twitter developer page. When you Google Twitter developer page and search for Twitter API rate limits, you can actually get what kind of data you can work with. If you're a paying customer, if you're an academic, you can actually use more. But for our tweets, if it hasn't changed right now, the rate is 18,000 tweets per 15 minutes window, which means every 15 minutes you can extract 18,000 tweets from Twitter. That's what they allow. If you want to get more, you do what we call you do the things that we call as for loops. You have to introduce a loop which should be in the form like extract data when you reach 17,999, wait for 15 minutes. After 15 minutes, retry again, retry again, retry again, retry. So you basically create a loop. You can set that loop for, you can say, I want 15 loops. Or you can say that until you reach 1.5 million tweets, stop. So you basically introduce conditional loops. But for now, we don't need that. That's a bit intermediate. We only need 18,000 tweets per 15-minute window so that we are still...
Question, sorry to interrupt. There's a question.
Yep.
Says, is there any approach or solution for eliminating trolls and fake accounts?
That's a very advanced question. First thing, I never want to eliminate trolls and I never want to eliminate fake accounts because that is data that I work with for different specific purposes. I'm a disinformation researcher, so I never clean trolls and fake accounts or bots because that is very valuable data because most of the time disinformation is disseminated through those accounts. In order for me to understand how disinformation is disseminated, I need those trolls and fake accounts. But if you want to get rid of them, you first have to get data. Then you get rid of those trolls and fake accounts. But then you have a bigger question. How do you define a troll or a fake account? Because what some people may call a fake account may not actually be a fake account. How do you define, how do you measure a troll or a fake account? Because in highly polarized settings, half of Twitter population would think that an account is fake or a troll, but the other half would say, no, that's a very legitimate account. So it's a bit tricky. One, I don't really want to get rid of trolls and fake accounts. Two, you can only get rid of trolls and fake accounts after you collect the data. So you have to, to clean them up in R. And 3, a troll account for me may not be a troll account for another person. So that's a very sensitive territory. So let's continue on with this. Like, let's first get our first real legitimate cool so the data, the code is as it is. HIMARS data, arrow, search tweets, HIMARS, n equals 15,000, include retweets, false. So when I run this, now it is taking a little bit slower to download multiple pages because it's going to Twitter, it's going to identify tweets that contains HIMARS in it. It's from the API bridge, it connects to your R, gets it into your session. So the progress bar moves a little bit slower and slower and slower. But essentially, the larger the database is, it's actually, you kind of get insights that you can't get with smaller data sets. So what we're going to do right now is that we're waiting until this tweet download finishes. So after this session, you can, try out different things like, I don't know, whether people, what people are saying about like Moroccan football team, about their, World Cup victory. You can do search terms such as Morocco. You can do search terms about, another war. You can do search terms about, a political contestation and a crisis. But since I have very little time in this tutorial, I'm only showing like the absolute very, basics of these things. If you need more advanced stuff, there are tons of good tutorials on more advanced stuff. You can always go to the Summer Institute in Computational Social Science website. So now it downloaded the tweets, but I'm waiting for those tweets to be shown in the environment pane. So right now it's taking all of that Twitter data and trying to parse it into my current session. It's taking a little bit of time. It may take about a minute or two, but when it is going to be done, instead of seeing 250 observations, which means, oh, okay, so now I have 14,837 tweets and 43 variables. Now, we are going to do a little bit of intermediate stuff of data cleaning, which we have to do. You'll be very confused by this, but it's okay. We're doing this because, as I mentioned, Twitter API has changed, and because it changed, the kind of output that we are getting has also changed significantly. So in the past, about last year, the codes that we ran for the previous API were a little bit different. Now, the current API requires a little bit of cleaning. So what I'm going to do right now, and I'm going to explain a little bit, but as I mentioned, it's not going to be very straightforward for you. Just follow along with me, and I can answer your questions along the way. So I have a box of tweets called HIMARS data, but the problem with this is that the usernames and the user IDs, the screen names, are hidden in this API. What I need to do is that I have to extract them or unpack them and reintegrate them back into the Twitter database. And I'm creating a new object called HIMARS data underscore clean. So this is going to be a new one. It's a clean data set. What it's going to do is that this is a new object, and I'm assigning that through an arrow, is that it's going to use the command called column bind. So what is a column bind? Just to give you a sense of what a column bind is, let me pull this through. I got lost in my own computer. Wait. So, okay. So a column bind is essentially this. You have a data frame 1, which is a collection of different columns. You have a data frame 2, which is another collection. When you column bind them, you get the second data frame and attach it at the end of the first data frame. Another way of showing it is that you have a data frame 1, a data frame 2. You use column bind to bind columns, copy paste columns into one single data frame. So that's what the command called cbind or column bind, that's what it does. So now what I'm doing is that returning back here, is that I'm using column bind on my original HIMARS underscore data, which contains my tweets. And from that, with comma, I am going to extract users data, meaning who actually tweeted those tweets, their user accounts. So I want to get HIMARS data, and from HIMARS data, I need to extract the user's data. This is a bit complicated, as I mentioned. It's a little bit intermediate stuff. It's going to be confusing, but don't be intimidated. Here, what I need is that the user's data that I'm going to extract from HIMARS data has to contain certain fields. Now, I need, so this is a new computer for me as well. I'm going to try to find, okay, you need the köşeli bracket, right? Not the round bracket. You need the arc, the rigid bracket. I don't know what the English term for that is. So here, what I need is that I'm going to input a command here, which says comma C, which contains, C is basically a vector. So in this vector, I'm going to add these following specific paths in that data. First, I need the ID of whoever is the user, separated by a comma, ID string, the specific ID numerical value of whichever user we're using, the actual name of the user as well, and their screen underscore name. So what the hell am I doing here? So as Twitter API changed, we have to adapt our code to the changing Twitter API. We didn't used to use this, do this before, but today, because Twitter API changed, in order to make that API communication faster with computers, Twitter decided to wrap screen ID, screen identification string, screen name, and name into a little box that if you need it, you can unpack it and add it into your data. And that's essentially what we're doing right now. We already have Twitter data. We are creating a new clean data set, but we are using column bind of HIMARS data. And from that, we are extracting users data and specifically adding the ID string, name, and screen name into our new data set. So we're binding the entire column into this. This is essentially called data cleaning or data wrangling. This is the most important part of being a data scientist. You know, producing nice visualizations, cool graphs, it's all fine. But this is what makes a data scientist a data scientist. You know, you are manipulating data so that when you're producing a graph, it looks accurate. So the code is as it is. So when I run this, it is going to create a new data underneath HIMARS data, which is called HIMARS data clean. So I'm running this code. And as you notice that underneath HIMARS data, I have HIMARS data clean. And instead of 43 columns variables, I have 47 variables or 47 columns. Now, since it unpacked all of these, Twitter data, there are some duplicates in my data set. Let's go here. So I have ID string, full text, everything is in order, everything is here. Favorite count, retweet count, everything is here again. But the problem is I have the names and I have the screen names. These are new, but when extracting them, I added an ID string extra into the data. So I have to clean them. I basically do this by removing duplicated column names. Very quickly, this is also a bit confusing for you, but it's necessary. We have to do another operation to HIMARS clean. We have to change this HIMARS. Sorry, I typed clear. It should be clean. Yeah, HIMARS data clean. So what this is going to contain is that the same data set, which is HIMARS data clean, and we're going to use köşeli brackets, the brackets that have edges onto them. I don't even know what the English for them is. I'm not changing anything in the rows, so I'm adding a column. But what I need is that I have to remove duplicated column names. I remove duplicated column names with the following function. Exclamation mark, which means remove, another way of saying remove in R. Remove duplicated. Okay, remove duplicated what? Remove duplicated column names. And in this context, it's going to probably remove ID and ID string. Okay, so remove column names from what? Remove column names from HIMARS data clean. So this is our code. HIMARS data clean, create object, HIMARS data clean, brackets. So this column here exists because if I had to do something with the rows, I would have to enter it here. So in a bracket or in a parenthesis setting, the first part before a column is usually reserved for commanding rows. The second part after the column is usually reserved for commanding the columns. So since I'm not giving any commands to the rows, that section is empty. So I'm adding a comma. After that, I'm going to say exclamation duplicated, meaning remove duplicated. from column names from HIMARS data clean. So I'm running this code right now. So when I run this, you're going to notice that in my environment pane, we used to have 47 variables for HIMARS data clean. Now we only have 45, which means that that extra ID and ID string parts are now removed. If we tried to do visualization with those, it would have given us an error. So we're essentially trying to prevent that error right now. Cool. So let me look at the chat, because now we're going to go into visualization. Square brackets, square brackets. So how are people doing? Is everyone following? Somebody, people already left out? Like, what's the situation with you? It's okay. It's going great. Good. So far, so good. Good. Very good. Okay, so it means that the codes are working. Those of you who are getting errors, probably you're typing things wrong. So you're not exactly copying what I'm writing, which happens in R and Python. Sometimes you feel like you're copying things exactly, but sometimes you're making a mistake. And especially people that are doing this for the first time, it's very normal to make mistakes. So like when this is recorded and put it on YouTube, you can always return back to this tutorial and, pause, type, and, follow it like that. So now I'm going to do the visualization, the fun part. So the first visualization that I always produce is to look at the time series dynamics of these things. So whether tweets are increasing or decreasing in a line graph. So we are essentially creating a time series plot. So the longer way of saying this is time series plot. But with the rtweet package, there is a command called ts_plot, which is going to give me that time series plot that we need to produce. So the command is ts_plot, parenthesis. What am I plotting? I'm plotting HIMARS data clean, comma. After the comma, I want these tweets to be grouped by a time interval. Do I want that graph to show minute intervals, 15-minute intervals, hourly intervals, 6-hourly intervals, daily intervals, or weekly intervals? Depending on how large your data set is, you need to tweak your date range. So let's say if you're looking at a tweet database that contains data from the last 6 years about US elections or whatever, you need to set a time frame in terms of months maybe. But with regard to HIMARS, we collected only 15,000 tweets, which is good, but not that much. So probably it goes, actually, let me check HIMARS data clean. I'm looking at the created at section. So it starts today, it goes, these are all today. It means that HIMARS is very popular right now. So I'm scrolling all the way down to the data set. So, okay, it goes to the 2nd of December. So it goes about 9 days ago. So one way of parsing this would be double quotation marks. I'm going to parse this. Let's try 15-minute intervals. I'm going to, give you some time to tweak this, change this, and whatever. So at the end of this line, I am going to go into the next part. So I am going to use the plus sign and type enter. You are going to notice that the cursor blinks slightly indented, which is good because right now we're still typing the tsplot command. Everything that we are typing belongs to the tsplot command. So here, those of you who are new to R data visualization, in R, the most popular data visualization package is called ggplot. And the tsplot command that we're using actually uses that same ggplot command. And with ggplot command, there are themes, color themes, font themes. You can specify all of them as you like, font size, font color, interior color, exterior color. You can all do these things as you want. But for now, we're trying to produce, a very quick graph. So I'm just going to say theme underscore minimal, which is a minimalistic theme. Again, plus sign, I'm typing enter and moving on to a new line. I'm still manipulating themes. Let's introduce like a title to this graph, like a nice title. So in this theme, we need a plot title. And instead of just writing what I want as a title, right now I'm entering specifications for it. So let's make it bold. Now, if you were to do this in Excel, these were very simple because you would just type it. In R and in Python, you have to type. You can't just click. So we have to say plot title, element, text, space equals, double quotation marks, bold. That's how you make a plot title bold. It's going to sound confusing and difficult at first, but the more you do these things, the easier it gets. It's just like very confusing at first. We are going to continue. Now, I like to add some labels to it. And the command for that is labs. Instead of labels, we just say labs. We add a parenthesis. So what should be the x-axis? X-axis label should be something like time. And the y-axis would be something like tweet frequency. Before closing the parenthesis, I'm adding another comma and going into a new line. And now I'm adding the title of this graph, which would be frequency of HIMARS related tweets. Yeah. And maybe a subtitle to this. Really cool. Of aggregated by 15-minute intervals. And maybe a caption. This is just like trying to show you different ways that you can manipulate a graph. Data collected by our tweets through REST API. So going back to our code, we are creating a plot, so time series plot. So all of those lines specify what kind of time series plot we're trying to come up with. We are visualizing HIMARS data clean for 15-minute intervals, minimal theme. I only want plot title to be bold, and I want labels of the x-axis to be time, Y to be tweet frequency, its title specified. So now I am going to run this whole paragraph, and I have my first data visualization. I'm going to give you like a minute so that you can produce the same thing yourself as well. Before you, while you type this, so let's look at everything we did on this graph. So our plot title is bold, like it's a thicker font. A frequency of HIMARS related tweets, aggregated by 15-minute intervals, data collected by RTweet using REST API, which is at the bottom of the graph. In terms of labels, the time, as you see, is on the x-axis. The tweet frequency is on the y-axis. And this is basically the time series visualization of the graph that you produced. Now, we see that there's a pattern here. It basically moves in and moves up, which is quite regular. We're not going to cover it right now, but usually the second question for research we would get is that why are these things increasing and decreasing? And specifically, why is it increasing that much in December 5th? And why is it increasing that much in December 11th? There's a little bit of like data problem at the end, but my initial guess would be that at the night of December 6th, at the night of December 5th and at the night of December 11th, probably there was a HIMARS attack that all of the tweets related to HIMARS increased. And the last one shouldn't be surprising because remember why we picked the HIMARS keyword to begin with is that I'm interested in the war in Ukraine. And just yesterday, there was an attack on Melitopol using HIMARS rocket artillery. So the increases are probably determined by the attacks. And usually when you're doing social media analysis, daily increases and decreases are usually related to day and night. In day, people tweet more. At night, they sleep, so they don't really tweet that much. How are you guys doing? Have you produced the visualization? Who managed to produce the visualization? Say, I did. Those of you who did. I did. Okay, cool. Awesome, cool. We did. Okay, good. So maybe, do we have time for another visualization? What's my time?
Hocam, we have passed our time, but if you have time and people are here want it, we are free to go.
Okay. Those of you who want another visualization, say, I want another visualization. Please continue. Yes, please. Yes. Okay. There are lots of like capital letters and exclamation marks. So, okay, let's continue. This is not going to take that much time because the biggest time always goes to data collection and data cleaning. That is 98-97% of your time. You have to do data cleaning and collecting data well. and data visualization is usually, there are set codes for that. But even if you produce the best visualization in the world, if your data is dirty, meaning it's not clean, it's not coherent, and it's not meaningful, the beautiful visualizations that you produce are essentially meaningless. So our time, 95, 98% of our time should always go to learning data wrangling, data cleaning, data manipulation, column binds, row binds, cell replacements, managing not available data. That is the core of being a data scientist. Visualizations, every single day a new package is created. You use the package that you like, you learn that package in 2 to 3 days, and you can basically do it. So
John, before we continue,
yes.
there's a question in the chat by Ansar Ajam. So I think he says, I want to extract tweets with minimum 1,000 files between years 2015 and 16, for example. So how can I learn?
Yeah, it's
that kind
doable.
of tricks?
I don't know if our tweet package has that, but academic Twitter, Python people use Twark or other Python packages. Our tweet doesn't have that. We basically do this after downloading all the data and then sorting our data based on 1,000. So the first thing I would do with our tweet is just get all the data about that specific keyword from 2015, 2016. When I have all that data here on my resident R, then I would sort them according to 1,000 faves and above, and then take them into a new thing. But I don't know if Twitter, well, I mean, new Twitter API should support that. Probably it should be doable. But you can learn those kinds of tricks by reading documentation of the packages. So you can read our tweet documentation, you can read academic Twitter documentation, you can read, if you're using Python, you can read Twark, or was it Twitter Py or PyTwitter. You can use their documentation. In their documentation, they specifically outline what each command does. So probably the best way to infer them would be to just read documentation. But like, I'm old, so Tweepy, yes, Tweepy is also, Tweepy is also very useful. But how I would do as a dinosaur would be, I would get all that data, and then once I get that data, I would clean about 1,000 faves. We didn't specify any time column for generating time series plot. How did our understand created that column? It didn't. We required 15,000 tweets, so it basically chronologically went 15,000 one by one all the way to wherever that 15,000 tweet ends. So every single tweet call that you make goes back chronologically. So if we wanted 1 million, it would go even back, even back, even back, even back. But if you wanted to do that, so many questions. If you wanted to do a date specification, we could have used created at specification, but that's a bit intermediate. It requires some data cleaning, so I didn't do it here right now. Can we make causal inference among these variables by quantifying? Yes, of course you can. I mean, you need some more additional data, probably. Why do people tweet more at specific parts of the day? Because they are either eating a lunch or in the commute, that are just like, they have tons of time to spend, that are tweeting all the time. So causal inference as well. We can use KNIME as well. You can, but R and Python will always be much more powerful and much more capable compared to like, why would you use KNIME at all? So let's continue. So let's look at which accounts are the most active, who tweeted the most, because when you're using like influence analysis during like a political crisis or a war, which accounts are like driving the whole thing, who are, over tweeting. We do that by, let's produce like a bar graph, like bars of the most popular. Okay, so we are continuing with our codes. HIMARS data clean. Now let me introduce you to another symbol. Out of all strange R symbols, this is probably the strangest, the pipe function. Percentage greater than percentage. So this is called the pipe function. A pipe function is exactly what it does. It connects chunks of code into each other through like a pipeline. So what we're doing is that basically we're entering a chunk of code using the pipe function, linking another code to it, adding the pipe function, linking another code to it, adding the pipe function, linking another code to it. So this percentage greater percentage sign is called the pipe function. And this means that I'm taking the HIMARS data and now I'm linking it to the commands that are going to come after. So in order to get who was really so active, we have to count. We have to count the occurrences of screen names. So we have to do count screen name. And we can work with screen names thanks to these two codes that we wrote above. Before Twitter changed its API, we didn't need these two lines. We could just like get screen name right away. But now, since Twitter is changing everything, Elon Musk bought Twitter, everything is just up in the air. We need to adapt to different API rules or different API structures. So we have to adapt our code as necessary. So we have to count the screen names and we have to sort them based on how frequent they are. So the sort has to be true. Then, again, pipe function, we go to another line. Now, we have to reorder everything based on whoever's screen name is the most popular. Popular meaning whoever like tweeted the most should come on top. And we do that through the mutate function. We mutate by screen name, and we're going to reorder them by screen name, comma, the number of occurrences that they appear in the data set. So let's say, let's say in our 15,000 tweet database, there are maybe 7 or 8 people that are really overactive. They're tweeting all the time. So we need to combine all of those tweets according to screen names and count those screen names so that the most active of those screen names lie on top, and it basically declines by how less popular they are. Again, pipe function, how many people should we want? So top n. So we can basically give any number to this we want. Let's look at like top 10 most popular accounts. You can change that to 15, 20, depending on the size and scale of your research. Again, a pipe function. Now we are going into a new command called ggplot. Now, ggplot, remember, it's the most dominant data visualization package of R. Any kind of visualization that you want, line graphs, bar graphs, violin graphs, network graphs, you do that with ggplot. So a ggplot command usually starts with the question of where will the data come from? What will that visualization show? And that command is determined by the AES function, aesthetic mappings. So an aesthetic mapping requires an x-axis, a y-axis. If you're doing a three-dimensional analysis, it requires a z-axis. But for our purposes, it only will require an x-axis. And maybe let's put screen names into the x-axis. And for y-axis, let's show the number of their tweets. So when I say like account number 1, how many times they tweeted, account number 2, how many times they tweeted. So let's go on like that. Now, dplayer, which is a data manipulation package, it uses these pipe functions. So you basically link commands to each other with pipes. ggplot links commands to each other with the plus sign, just like we did above. We basically link them with plus, plus, plus. This is a very confusing part of R. I understand when you're learning these things for the first time, it's very confusing. You know, we used to do these with pipe, so suddenly we turn this into pluses like Y, because I mean it's confusing. But when you do these things for a long period of time, it doesn't become that confusing. So we add plus, go into the second line of ggplot. So what kind of visualization do I want? What kind of geometrical representation? Geom. Geom AB line, geom area, geom bar, geom two-dimensional bin, geom box plot, contour graphs, crossbar graphs. So the entire visualization library of ggplot is here. It's contained in the geom function. So here, what I want is a column graph. I want a column graph, which is going to put these things in column formation. Then let's specify colors. You can specify any color that you like. Sorry, it's not colors, it's color. So it's supposed to be color. So you can use, you know, hex codes, you know, the specific hues and specific everything. You can enter, you know, specific hex codes into this. If you want a certain shade of pink, you can basically go up into, you know, a hex color editor and find whichever. But if you're not that specific about the color that you want, you can just add red in double quotation marks. The color determines the border color, by the way. It's a shame that they don't specify this as such. When you say color, it should say that's the border color, but color in this context is going to determine the columns, and the fill color is going to contain the color for the interior of our bars. Let's say it's a blue. You can change them if you want. If you want like yellow, green, whatever, you can just, you know, write them. Plus, I'm going into the new line. Let's work on labels. So x-axis label, y-axis label. So x-axis should contain usernames. Y-axis should contain maybe again, double quotation marks, tweets counts. Okay. Then maybe the title of my graph would be top 10 most active HIMARS accounts. Yeah, so that's basically the code. I got HIMARS data clean, counted each screen name, sorted according to their numbers, then mutated the data set so that the most active screen name appears on top and basically goes down in a descending fashion. And I'm separating the top 10 and taking those top 10 and introducing them into a ggplot function. And the ggplot function will convert them into bar graphs or column graphs. So when I run this code, I get the following visualization. Let me zoom. Let me zoom this a little bit so that. Okay, so Coach Scott Fan, HIMARS Mans, On Fire Ukraine, Kane 1952, HIMARS O'Clock, Top 9. So these are all usernames. Some of them may be real, some of them may be not real, but in the war in Ukraine, we discovered significantly that there are lots of anonymous accounts that are dominating the information space, and it's very hard to determine who they really are. My only problem with this graph is that since screen names are so long, they basically kind of move into each other. I'm going to fix that, and it's actually a very easy thing. So at the end of my last paragraph, I'm going to add another plus. I'm going to type enter, and I'm just going to type coordinate flip, which is going to take the x-axis and move into the y-axis, and take y-axis and move into the x-axis. So I'm running this again. Yes, this is much better. So now everything is tidy. I have usernames clearly legible, tweet counts in an increasing fashion. Yeah, so that's basically a very fundamental way of doing like very basic Twitter analysis with Twitter data. Of course, there are much more sophisticated stuff people do with these things, but usually even in my lab, I get my assistants to do these visualizations first so that we have a sense of the general direction of our data. First, we need to understand what our data is and its main parameters, and then we determine what we want to do with it. If we want to do text mining, topic modeling, network analysis, machine learning, that kind of stuff. But in order to be able to understand whether we need them or not, we first need these very simple elementary graphs to understand what's happening with our data set. So that's it from me. Do you have any questions? Now I can see the chat. You can also like speak if you want. Alperen Urfaloğlu, yes.
Well, thanks for speech and the presentation. I want to ask the question that, I mean, we are gathering all this information from Twitter or other kind of social media platforms. If these platforms decided not to share this information with us or with developers or something like that, I mean, you said that at the beginning of the presentation. I mean, there are good ways to get all these kind of data. If they refuse to share all this information, is there any other way to gather this information, or is it okay to gather the information from our with our ways, and then with the some kind of methodology, and then we can show other people or the authorities that we are doing this for good, not for our own goals? Is there any kind of methodology or way that we are collecting this data, but we are doing this good for good?
Yeah, I mean, you can scrape, yeah, I mean, if you want. There are ways of scraping without getting detected, but I don't really recommend it because as a scientist, I can't use them because at the end of the day, I need to be able to publish them. My PhD students or my master's students should be able to, write thesis, write articles out of this, and they can't do it with scraped data. That's against research ethics. For government entities, for companies, that's not that big of an issue because they're not publishing, they're just like using that data for other purposes, so they do a lot of scraping. But scraping is one way, but if a social media platform stops sharing data, Facebook did that before the Cambridge Analytica scandal. Facebook had a very good API that we could use for research purposes. And then because Cambridge Analytica used that same API interface in order to mess things up, Facebook basically just closed all of its API for research purposes. And it's right now only for developers and advertisers. You can use it for research purposes. Yeah, Albert Hoca mentioned it. There's Ingmar Weber who's working on this. But of course, the kind of data that we get is not as rich as it used to be. So Twitter is one of those companies. I used to be part of Twitter's new research API. They wanted to open up that for research purposes, but at the end of the day, they lost so much money due to Cambridge Analytica scandal. They just don't want to open up. And the same thing goes for TikTok. I'm trying to get TikTok to open up a research API as well. Let's see how that goes. I don't know, but any given time, these social media companies can close their APIs. That's life. That happens. When that happens, there are two ways. One, as I mentioned, you just scrape and stay hidden, but then you can't publish it. Then you can also send the developer team or the security team of Twitter a research application saying that, I have a PhD thesis like this, and this. But in these kinds of situations, students or researchers from more established and well-known universities like Harvard, Oxford, their requests get accepted very easily. But if you are an unknown university from South Africa, if you're like a B-level university from I don't know, India, they don't even take you seriously. That's how things are. So that creates great inequality and access to research. When you're from Harvard, from Oxford, from Yale, you can get access to even like hidden API data, and it's just like they give it to you like that. But for researchers from other parts of the world, life is very tough and life is very difficult. In these kinds of situations, you have to partner with researchers from well-known institutions. You have to send them an email, say, I'm doing research like that. Would you be interested in sharing data with me? But in that context, you have to have a research project that should excite people from more influential universities. So that's how the state of the nature is at this.
Thanks for answer. I just want to elevate, the point onto a specific point. As you said, when the things are closed or the institutes has decided to not give us the permission, I want to ask that if is it possible to develop a standard by the universities? It doesn't matter who develop it, and if the university decided that, well, if you want to do research, if you want to do scraping, and if you follow these standards, it is okay to publish your work as an academic area? Is it possible to develop such a standard, system of standards?
It is possible, but it hasn't been developed yet. Okay, any other questions? Cool. So I have to go. Take care. I hope you had like a nice, gentle introduction to Twitter analysis with R.
Thank you, Hocam.
As I mentioned, more resources are in several places. Let me show them to you as well, so that if you want to like train yourself on this, because universities are often very disappointing in that manner. So our studio tutorials. So there's a great place called education.rstudio.com. It takes you from the very beginning, like how to install RStudio and packages, and get you to like intermediate and advanced levels. So it's a very great place to start. Then if you're more interested after doing these things, we have lots of good stuff in Summer Institute in Computational Social Science place. And then of course, the best book around R for data science. R for data science is the best book on using R for data science. It's free, it's freely available online. It introduces pipe functions, it introduces how to use tidy data, factors, markdown, modeling basics. So there are tons of good stuff on how to use R. But for Twitter analysis, you have to, follow, probably the best way to follow that would be R stats, the best Twitter page for R users. There's a lot of good and useful information here. I would highly suggest you to go to Twitter and follow these accounts. Similarly, you subscribe to RStudio Tips. It's very useful. RStats question a day. And that's basically it. The more you do it, the better you get. So my suggestion is to just start working with anything that you can find, essentially. As you do these things, the better you're going to get. Don't be intimidated if you're like very if you're panicked for the first time. Don't be panicked. But cool. So take care. Thank you for the opportunity.
Thank you
And
so
I
much,
hope
Hocam, for accepting our invitation.
Yep. Cool.
Coming here, doing workshop. Thank you for your time.
Yep.
And I'm also stopping